Welcome to the another session in Frontiers in CFD. So today's analysis is CFD and simulation of heat transfer in a heated circular tube. These are the objectives for today's session. First objective is to develop the 3D geometry of circular pipe with specified heated section, to generate an appropriate mesh and apply the boundary conditions and do the name selection. Third is to perform numerical simulation and analyze the flow and heat transfer characteristics. Welcome you all to the another session on Frontiers in CFD. Today we will see the CFD simulation of heat transfer in a heated circular tube. First of all, I will start with the workbench window. We will use the fluid flow Fluent model. The geometry preparation will be done with the help of design modeler. Then we will generate mesh and we will do the name selection, and then we'll run the iterations based upon the given boundary conditions. So let's start with the fluid flow Fluent. Here we'll prepare the geometry with the help of new design modeler. So first of all, set the units. I set it to millimeter. Click on any one of the plane and let us say XY. You can see the coordinates X, Y and Z. So this is also X, Y and Z. So accordingly you have to orient the object in a required direction. So let's go to the create. Click on primitive. I will select cylinder. Right now the object is oriented in Z direction. I don't want the object to be oriented in Z direction. I want it in X direction. So let's put the component X direction 1400. Let's make the Z component to be equal to 0. Now you can see the object is oriented in the required direction. Now our outer diameter we are going to follow is 12 mm. So accordingly I put radius that is equal to 6. So now I will first make it add to frozen and will generate. So you can see a pipe, a solid object is generated. Again this is a solid object as of now. We have to turn this object into a hollow part. So one of the simple thing which we can do is we can use as a thin operation here. You can click on yes and you can specify the thickness of the pipe. So let us say we put it 1 mm and let's click on generate. So you can see now the object become hollow. In this way you can make the object hollow from inside. Now it's time to define the fluid zone. So go to the tools, use the fill command. We need to fill the cavity of the pipe. So you have to select the appropriate option. You can see the Y cavity. So I select this internal zone, make it apply and then click on generate. Right now you have to see here it is showing one part one body only. If I click on generate, it will show you two part two bodies. So one of the part is for your solid, second part is for your fluid, but it has taken the name as solid because the object has been generated from the parent. So this is the parent object, that is solid. So that's why when we do the fill operation, in that fill operation you will see the same name as appeared. So we need to change this name. So I just click on rename and I use the name that is fluid. So first one, this is your solid and this is second one is your fluid. So here also I will put it as pipe and second one here it is a fluid. Now you can see in the definitions this is solid specified, in the fluid it is by default fluid is specified. So this is the one thing that you have to always check when you prepare the geometry. Now with this particular section of the pipe I need to divide the sections into 3 such segments where it will be easy for us to apply the boundary conditions. So let's click on new plane. Now I want to generate a plane with respect to some base plane. So I select from plane. Now I will generate with respect to Y and Z. The reason why we are doing this because I want to slice the geometry along YZ. So I select YZ here, make it apply, and then click on offset. So offset, I will put it the value that is equal to 100. So as soon as I put 100, you will see the object has reached here. So let's make it generate and do the slice operation. So make it apply and click on generate. So you can see this object has been separated out here. Now one more time I click on one more plane. Now again we'll select is from plane. Either you can select from this location or you can select this also. So here I select it from plane 4, make it apply and click on offset Z. So I will now select 1200. So now click on generate and then do the slice operation. Make it apply and generate. Now you can see this is the part which has been a slice, and this is also, and the other one. Now let's identify the fluid zones which are present inside. So this is the first fluid zone, the second fluid zone, and the third fluid zone. Now we'll make this fluid zone as unite. So you have to go with the boolean operation. So let's make it apply and click on generate. Now you will see the pipe sections are 3, 1, 2 and 3, and based upon this you can just check it out. The fluid zone is only 1. So in this way we have prepared the geometry. So this is the pipe which is at the right end. I may define here itself pipe. I will write right end. Then this is a pipe. I will define as a left end. Then this is a pipe which is at the middle. I just put M. So these are the 3 things I have: pipe middle, pipe end, then R end. So this is my fluid. Now I just go to the next step, click on mesh and click on edit. So this may take some time. So once the mesh is open, you will see the object is loaded. Okay, if it is not there, just click on close the meshing part and reopen it again. So let's click on mesh, click on edit. So now you can see the object is loaded. You can make it fit to window and we can visualize the object like this. So this is how the object has been appear. In the geometry also you can see pipe right end, then the fluid zone, pipe left end and pipe middle. So let's first generate the default mesh here. So this is the mesh which is generated by computer by its own understanding. Let's see on this side how the mesh look like. Okay, so may not be satisfied with the given quality of mesh. So right now it shows around 93,105 and 66,492 as a, we can say, elements. So we are not satisfied with this mesh size. So I just go with a different element size here. So I put it 0.005 and let's make it generate. So now no such changes appeared as per the number of nodes and element. So now I put it 0.0025 and let's make it generate. So we can test with different number of nodes and element as well. So with this also we don't observe any change. So I put it 0.001 and let's make it generate. Now we took the element size which is slightly on the lower side, uh, smaller size, so 0.001. I will put it 0.0005 and let's make it generate. So the one which looks satisfactory, for that we will go with this element size. Again, if you want to do some mesh independent study, so that time you can just check out with the different element sizes and accordingly check out what are the results which are coming out. You may also check out how much of the temperatures which are maybe at the outlet with the element size which is 0.001 or the element size which is 0.005. Based upon that we can actually observe the variations. So right now it shows around 27 lakh 87,528. These are the number of nodes and element which we are having. So this is looks to be comparatively on the finer side here. Now if you are satisfied with this mesh size, you can go ahead with this, or you can just change the element size. So now I will put certain name selections on the geometry. Let's put this as your inlet. So I specify this as a inlet. Similarly on the other side, I will specify as a outlet. So let's specify this as an outlet. Then specify the walls. So I will select this here. Okay, so I will select this one first as the heated wall. So if you want, you can put it somewhere here also as the wall at heated pipe at left and right end and so on. Or you can skip it also. So we have done three things. One is inlet, then we have selected outlet. So this is your inlet. Just check it one more time. Inlet will be on this side. Here you can have. Then outlet you have selected on the other side. This one. And you selected the heated wall here. So in this way we have done the mesh on the given geometry. Let's click on update. So you should see a mesh translation to Fluent successful message once the mesh is successfully updated. Once that happens, you can actually close the mesh window. So let's go into the file and click close on meshing. Now we'll move to the next step. Once this window is closed, we'll go to the setup part. So before proceeding for the setup part, I just click on save button. I will save this work. So I just put pipe heated at middle. Just give the name pipe heated 600 watt. So this is the name we are given. Now we have saved the work so that even if some failure occurs in terms of power, we can access the work later on. So the geometry option is also not required now. You can close the geometry part. Now we will move to the setup part. Let's move to the next part, that is setup. Click on edit. Select the number of processes. I just put it 18. Click on double precision. Click on start button. So depending on what element size you are selected, the time requirement will be slightly more or less. You can do the parameter study as well. You can check out with the different element size, and you can check out how the results varies with respect to different element size. So this can be considered to be the mesh independent study. So once the object is loaded, we'll proceed for the next step. So you can see the object has been loaded. Let's click on OK button. Make the titles to be visible here. Accordingly, you can say zoom in. You'll see the red arrow, on the other side you will see the blue arrow. So that represents the inlet and outlet for us. Now we are dealing with the temperature parameter. The things will go on to change with respect to time. So we'll enable the transient model. Then we'll specify the gravity minus 9.81. Why minus 9.81? This is positive direction of y. So gravity should act in the downward direction. Next, go to the model. I just click on energy equation. Turn the energy equation on. Then in viscous, go to the K epsilon, enhance wall treatment, thermal effect and curvature correction. Let's make it OK. Once this is done, depending on what model you are using, so here I just on energy equation and the viscous model which I consider with K epsilon. Now go to the materials. So I just go inside, go to the Fluent database. I need water liquid as a fluid. So search for water liquid, make it copy and then click on close. So air is the default material which is available. Water liquid again is a default material, the material which we added. Then solid, the default material is as of now is aluminum. So if you want some different material, you can add the different material as well. So you just have to go inside, select the solid and you can add from the list of operations which have been available. So I am not going to add any additional material. I will go and use with the same aluminum as a solid material. So we have added water liquid, air was by default, aluminum was also by default. As I said, if you want to add any specific material, you can add that material as well. Or if you want to test with the two different materials, one is aluminum, second is copper and so on, you can add that material and you can run the multiple combinations as well. So now next go to the cell zone condition. So here I will just select the zone type. Now we need to tell the computer which zone corresponds to which fluid. So let's click on fluid. I click on edit. Here water liquid will specify, make it apply and then close. Here pipe left end, right end. So the material is only one, that is aluminum. As we are not added any external material, so that's why by default option the aluminum will be there. Now next thing is you have to apply the boundary conditions. So go inlet and apply the velocity of fluid. Let us say I am putting here 0.015 meter per second. If you want, you can apply different velocity as well. So this is the default temperature I am considering, but in your case, if you have some different value of temperature, you can specify that temperature and we can make apply. So we have specified the boundary conditions at the inlet and accordingly now we'll proceed further. So now heated a wall, we'll apply the heat flux on the heated wall. So I'll just put the value that is around 600 watt per meter square. Make it close. No other boundary condition you have to select or no other thing you have to change. If you added some different material, that time you have to go inside and you have to select the required material. But because we have not added any other solid material, the default option available is aluminum. But if you have added any specific material, you have to select always. And now I go to the report definition. So here go to the surface report. I click on area weighted average. Now select temperature. I select total temperature. I want temperature at outlet, so I just selected outlet option. Now go here and select temperature at outlet. So this report definition will be generated with the help of this. So next make it OK and then close. Then go to the initialization, click on initialize. Once initialization is done, the patch option will be visible. So we are not dealing with any multi-phase model, so you don't need to go with the patch option available. Click on calculation activities. I just click on autosave after 20 iterations. So I click on that. Solution animation, I just go inside new object, click on contours. I select temperature, I select total temperature and select all. So go to the, instead of exponential, I select it float and make it close and click on save display. Once you click on save display, you will see the animation window. It is changed with the blue color. Let's close this and click on contour 1 and define this. So we'll define total temperature system. So this is the total temperature of system animation. So let's make it OK. Next, go to the run calculation and run the iterations. Say for example, I put it for the first case, I put it 10 and let's make it calculate. So depending on whatever the element size you are taken, whatever the number of nodes and element are considered for your simulation, the time requirement will be more or less. So we'll just check out after 10 time steps what happened once this process is completed. So you can see the process that will start now. As I said, depending on how much element size you are taken, accordingly the time requirement will be more. You can see the iteration process has started. Once first 20 iterations are completed, you will see the window which we set earlier, that is the temperature at outlet, and second one is the animation window. So these are the thing will be visible once you have completed the first 20 iterations. So you can see now the 15 are left. So once they are completed, you will be able to see the animation window as well as the temperature curve window. You can now see the some windows are appearing. So this is the animation window which we have set. This is the total temperature at the outlet. So we'll try to run this for some time and then we'll visualize how this temperature curve and other animations are coming. So by that time we'll just wait till some iterations are completed and then we'll come back. First time step has been completed. You can see calculation complete message option. This is the scale residual. You can see the total temperature at outlet, and this you will see the contours of total temperature animation window. You can see the temperature curve rising up. Still we need to run it further in order to visualize the temperature curve. This temperature curve may get flat after some time, so we'll run it further. Before that we'll save the work. Click on save option. Once it is saved, you can click on calculate option again. So saving the work is done. Now you can go and run the iterations again. So I will put it now slightly higher value, let us say around 20, and click on calculate. We'll wait till this 20 iterations are completed and we'll check out how the temperature curve responds after 20 iterations. We are running the simulation for around 50 seconds as of now. We need to run it further in order to get the temperature curve slightly on the flatter side. So this is the current situation as of now. You can see here. So we'll run this further and we'll check out what will happen at the end of next 20 time steps. So the simulation is completed for around 110 seconds. Just see the scale residual total temperature. So this is how at present situation. We'll run it further for more time steps so as to visualize how the curve will behave after some duration of time. So let's run it again. Before that, let's save the work. So we'll run this for some more time, maybe around uh, 40 to 50 seconds more, and then we'll visualize how the curve will behave. The calculations are completed up to 170 time steps. So still we are not observing any flat curve. So we'll run it for further, maybe around 40 time steps, and we'll visualize how the temperature curve will behave. So let's save the work and run the simulation again. You can see now the temperature curve is getting flat. So this is your temperature. So this is temperature of the system at outlet. So we can see here. So this curve is likely to get flat. So we'll run it further around 30 more time steps. So but the tendency of the curve is now becoming complete flat on this we can say time step around 248 we can say second. So let's wait till the remaining 31 time steps are completed. We'll check out what will be the behavior of curve, and then we'll generate the post processor simulation. So only one time step is remaining. You can see the curve has become completely flat. So we have run almost around 300 time steps. You can see the temperature remains constant at around 305 Kelvin. So one last step which we have to see, and then we'll go to the post processor. So you can see the curve, that is the total temperature at the outlet with respect to flow time. So this represents the animation which we are run. Sorry, this one represents the animation window which we have set. So we'll try to visualize this in post processor once the work has been saved. You can see the calculation complete message. Go and save the work. Click on save button. Once it is saved, you can go for the next step, that is for your post processor. Click on edit. If you want, you can close this window as well. So let's say first of all we'll try to visualize the the flow which is taking place from inlet to outlet along with the temperature streamline. So it may take some time to load. So first of all select inlet, outlet, pipe contact regions. So in this way I selected all. Now we'll specify the transparency for them, 0.9. So we have to do it for all ends. So put it 0.9. Similarly for other end as well, 0.9, or you can 0.95. Make it apply. Last one outlet, specify 0.9, make it apply. So in this way you can see, okay, on inlet also will specify 0.99. So we have set the transparency for the object. Now let's specify the temperature volume rendering. So I put it the value of temperature, use the value of local, increase the resolution to around 100. So make it apply. So once you click on apply, volume rendering will be generated. So depending on how much resolution you are selecting, the time required will be more. Once this is done, we'll set the temperature streamline. See now the temperature volume rendering is available. So we have selected the local scale. So let's make the scale slightly better. I will make it at center. Appearance I will make it, instead of scientific I will make it fixed. The number of value tricks I will put it 11, and the size I will change here. Let's see what difference occurs here. So in this way you can see the object with the temperatures volume rendering. So let's make it slightly bigger so that to have better visibility. Now let's assign the temperature streamline. So go with the streamline option. Now in streamline option, select from where to start. I will select it an inlet. Color I will select a variable as temperature, and range I will set local. Again I just click on apply. Once you click on apply, you will be able to see the temperature streamline as well. So within this you will be able to see the temperature streamline. I just uh, see here, you can see the temperature streamline which are been generated. So let's zoom out again and let's run the simulation now with temperature streamline first. So I will select the sweep animation, say streamline 1. Then if you want, you can select the wall size to be comparatively low. So I take it 0.48 and let's click on play button. You can see the particles are moving from one end to other end, and they are also taking heat from here, and that's why the temperature at the end it is increased. So in this way we can visualize the simulation. If I want to save the work, you can save the video file here as well. So click on save movie, select the folder where you want to save this file. So prepare a folder, say pipe with 600 watt. So I save it by pipe with 600 watt. Click on save, go to the options, you select the video width 3840, then 2160. So this is I am specifying with 4K format, and then click on advance, save as a frame, save as a output directory. So go to the document and pipe with 600 watt, select choose. You can select the frame rate as well, and then you can make it okay. Once this is done, you just have to click on play button and the files will be saved in the respective folder. Now you will see the simulation rendering has started. So let's see where this is getting saved. So you can see some animation files are been getting prepared. So 34, 35, 36 and so on. So this animation file will represents the path of the particle, how it will taking the heat. So this will be all visible. This process will stop when we complete the animation frame of 1000. Then this process will go on to stop. So we'll wait for some time till this complete process is over, and then we'll check out what how will be the video that has been generated. So let's click on now how to see the how to generate the graph. So that I will show you. Go inside the folders. Inside of your folder you will see one of the report definition file, open with notepad. So you can see the values are already selected by me. So now all these values will copy at some other place. So let's make it copy. Let's prepare one more folder here. Let's have a Excel file. So I select a Microsoft Excel. So I put it, say, graph, and go inside. Now copy the values which we had. Click on control, use text import wizard, click on next, and lastly finish. So we'll see the third column. So third column is not required. So I will just go with the 2 1. So one of them will represents the flow time. This one represents the flow time, and this represents the outlet temperature. Now let's prepare the graph for these two. So to prepare the graphs for these two, select all these two values throughout 300, then go to the insert and recommended charts. So I select the first one. You can see the chart has been prepared. So I will select the titles, axis titles. So this represents the flow time, and on the other side it represents the temperature. So you can see clearly the temperature curve becomes flat. You can see the temperature curve becomes flat after some time. So in this way you can save your simulation and the graphs. This represents the outlet temperature with respect to the flow time.